Hello friends, welcome to my channel. We are going to prove that square root 2 is an irrational number. So with this proof, we prove this theorem by method of contradiction. So first of all, we assume that square root 2 is a rational number. So assume that square root 2 is a rational number. Rational number. So we can write this as a is in the form of p upon q. So square root 2 equals to p upon q, and p and q are integers, and q can not be equals to 0, and p and q are co-prime. P and q, pq are co-prime. That is, common divisor of p and q are 1. Common divisor of p and q are only 1. So again we can write it as p equals to, we can write this equation square root 2 equals to p upon q as p equals to square root 2 q. Squaring both sides, squaring both sides, both sides, we get p square equals to 2q square. 2q square. So what this becomes? Again, this implies that 2 divides p square. Vertical bar a vertical bar b means a divides b. This is notation. A divides b. Again, since 2 is a prime number, so 2 also divides p. Since 2 is a prime number, so 2 is a prime number, so 2 divides p square, therefore 2 also divides p. This is the fundamental theorem of arithmetic. Again, this can be taken as equation 1. Again, what we do? So by equation 1, by division algorithm, p equals to 2k for some k is an integer. Again, by star, by equation star, since 2q square equals to p square, so this becomes 2k square, and this can be written as 2q square equals to 4k square. And what implies that? This implies that q square equals to 2k square, and this can be written as, this means 2 divides q square, and this means 2 divides q also. And what is meant by this? 2 divides q also. So this is the equation number 2. By equation 1 and 2, we have seen that 2 divides p and q also. So by equation 1, by equations 1 and 2, not equations, sorry, this is not an equation. By 1 and 2, 1 and 2, 2 divides p and 2 divides q also. So this is a contradiction, that this contradicts the facts that, this contradicts the fact that p and q are co-prime. That is, the GCD of p and q must be 1, but here we see that the 2 is a positive integer which divides both p and q. So this is a contradiction. Why this is contradiction? Since therefore our assumption is, therefore our initial assumption is false. Initial assumption is false. What is this mean? What is meant by this? This means that square root 2 is not a rational number. Since square root 2 is a real number, so if it is not a rational number, so it is a irrational number. So square root 2 is an irrational number. We have proved this. So thank you.